Hi, welcome to my video on a further explanation on even and odd functions with absolute value. And this is number 1 on that topic. Graph f of x equals the absolute value of x. So I'm going to graph this, but before I do, let's decide if the f of x is an even or an odd function. So here's the equation, f of x equals the absolute value of x. So the f of negative x is equal to the absolute value of negative x. The absolute value of negative x is the same as the absolute value of x. So that means that this is the absolute value of x is f of x. So that means the f of negative x is equal to the f of x. So therefore, it's an even function. Now, to look at that in terms of the graph, the definition of the absolute value function is in terms of a piecewise function. And that is, the absolute value of x is x if x is greater than or equal to 0. And the absolute value of x is a negative x if x is less than 0. And this is the official definition. And we always say that the absolute value is always positive, but it's based on this definition. So now what real number you put in here, you're always going to get a positive number coming out because of this definition. Which means that if you take this one right here, y equals x, where x is greater than or equal to 0, that means when x is 0, y is 0. When x is 1, y equals 1, so x is 1 is y 1. X equals y, 2 gives you 2. So on this side, we have a line going like that, which is, it's the upper part of y equals x because it comes on down there, but we can't go down there because we can only have x is equal to 0 or greater. So this is, and we also have the line, or part of a line, y equals negative x when x is less than 0. So x is 0, we get, if x is 0, we get y is 0, so it's right here. And when x is negative 1, so the negative of a negative 1 is 1. So when x is negative 1, y is 1. And when we take x is negative 2, the negative of a negative 2 is 2. So negative 2 gives you 2. So on this side, we have this side. And that's the graph of the absolute value, which is a V shape with a vertex of 0, 0. And notice this plus is going up. So that explains the definition of the absolute value of x. So let's always remember that, which we did. I explained that in my previous unit in Algebra 2. On absolute value, Algebra 1 also had some problems. So let's look at this graph. What about 1 over, which is the reciprocal? Is this f of x equals 1 over the absolute value of x? Is it even? Well, f of x equals 1 over the absolute value of x. The f of negative x equals 1 over the absolute value of negative x. And so that's 1 over the absolute value of negative x is the same as the absolute value of x. So 1 over absolute value of x is the same as the f of x. So that means that the f of negative x, is equal to the f of x, which means this function is even. I want to go back to the previous one. I forgot to mention. Let's go back to the previous one right here. And again, if this is even, it's reflected in the y-axis. So you can see that this part of the graph here, all these ordered pairs have this ordered pair. This is 1, 1. This one is negative 1, 1. And this one here is 2, 2, 2. So this one here is negative 2, 2. So all the ordered pairs here are reflected in the y-axis. Just want to mention that. So when a function is even, it's reflected in the y-axis. So again, this is even. So this function is reflected in the y-axis. And let's show that. Let's show that in terms of looking at the equation. So we have the equation, the f of x is 1 over the absolute value of x. So if we look at the equation, let's look at, this is a reciprocal, so it has the vertical asymptote, it has the denominator. So if we make the absolute value of x equal to 0, that means no matter, the only number you can have that is, what number can you take the absolute value? You have to give you 0, x is 0. So we have a vertical asymptote here at x equals 0. So draw it alongside of it right down through there. So there's the vertical asymptote, which is the y-axis. Now, what about the horizontal asymptote? So what happens if the absolute value of x goes to infinity, then 1 over the absolute value of x will go to 0. So if it goes to infinity, we have y equals going to approach, y is also, put an arrow here, y is going to 0. And what about the absolute value of x goes to negative infinity? The absolute value of x, let's make that an x there. The absolute value of x is going to negative infinity. That means that 1 over the absolute value is going to go to, make that an arrow, going to go to 0. So y is going to go to 0. So the horizontal asymptote is y equals 0. And that is the x-axis right here. So all that, what we're trying to say is that as x gets larger and larger and larger, this fraction gets smaller and smaller and smaller, approaching 0. Okay, and what about looking at the domain of this function? Domain are the values of x, and the values of x in this graph can be, in this equation, can be, you can't plug in 0, so x cannot equal 0. But that means if x can't be 0, x belongs to the real numbers, but it cannot be 0. And what about the range? The range are the y values. So if x can't be 0, that means y can't be 0, but the y values are, we can have any other number. So the y values in this are always positive. So the y can't be 0, but the y's are always greater than, not 0, but greater than 0. Because no matter what x is, this fraction is always positive. So the y values are always greater than 0. So that means the graph is up here, never down below because of this plus. And we have a vertical asymptote. So if the graph is up here with vertical asymptotes, let's look at a couple of ordered pairs to see where it's going. And let's look at when x is 1. Take this equation, put a 1 here. The absolute value of 1 is 1. 1 over 1 is 1. So 1, x is 1, y is 1. So that means that as x goes to infinity, the absolute value goes to infinity. As x goes to infinity, the absolute value is going to infinity. So that means it's coming out here. And as also, if you take values of x between 0 and 1, it goes up like this. It gets higher and higher and higher. So the closer I get to 0 on the right side, this goes to infinity. So if you took a half and let's take x to be a half. So let's do 1 over the absolute value of a half. So that's 1 over a half. So that's 1 times 2 over 1, which is 2. So a half right here gives me a 2. If you put a 1/3 in, you get a 3, so it's going to infinity. And what about we take the other side at -1? Put a -1 in here. Put a -1 here. The absolute value of -1 is 1. 1 over 1 is 1. So -1 gives you 1. So as the graph goes to, as y goes to -infinity, going to this point, as x goes to -infinity, y is approaching 0. And again in here, as you get closer and closer to 0 on the left side, this goes to infinity also. And there's the graph. Y's values are up there. As it goes to infinity, it's going to 0. As it goes to infinity, it goes to 0. And the two to our pot, so you can see that it's an even function. So all these ordered pairs over here, notice this ordered pair is 1, 1. This ordered pair is -1, 1. So the x values are positive and negative, but the y values stay the same. And that's true for here. If you took a half, you get a, let's say a half gives you a 2. That means if you take this one, and negative a half gives you 2 also. So it's reflected in the y-axis. Just wanted to explain that. Again, the absolute value function 1 over the absolute value is horizontal asymptote to 0, and it goes up no matter which side you go in on, left side or right side goes to infinity. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.